Welcome to STEM Pathway and welcome to our Grade 9 Integrated Science Midterm Revision. Today's session is a little different. We are stepping outside the classroom and into the field to bring science to life. In this video, we will go beyond the theory by connecting each exam question to real life experience. As we move through the field, we will explore the key topics including separation of substances and magnetism, the interrelationship between living organisms and their mode of feeding, the structure of the atom, the electronic configuration, and the dot and the cross diagrams. We'll also revise important concepts such as permanent and chemical changes, also physical changes, hard and soft water and their advantages, word equations, osmosis, diffusion, and pressure. Each question will not only be answered in details, but will also be demonstrated or explained using examples from our surroundings, helping you to understand, visualize, and remember better. Let's get started. The first question, a student observes lice in someone's ear. Explain the relationship between lice and the human being. So in this case, if you want to explain the relationship between lice and human being, in this case the relationship is parasitism or a parasitism relationship. And in parasitism relationship, one organism, that is a parasite, benefits at the expense of the other organism, which we call the host. So in this case, lice act like a parasite while the human being acts as a host. The second question B, give another example of a similar relationship and describe the roles of organisms involved. In this case, if we want to have another relationship like the one that we have up there between lice and a human being, in this case, another perfect example is a relationship between a tick and a cow. In this case, the tick, which is the parasite, its role is to attach to the cow's skin and suck blood to survive and reproduce, while the cow acts like a host and its role is to unwillingly provide nutrients to the tick. And in this case, the cow suffers from blood loss, skin damage, and may even be infected with diseases like East Coast fever carried by the tick. Question 2, an atom has an atomic number 17. Atoms with atomic number 17, this atom we call it chlorine, and a mass number of 35. The mass number of chlorine is 35 because it exists in isotopic form. So in this case, calculate the number of protons, neutrons, and electrons. In this case, what we know is that mass number is equals to atomic number plus the number of neutrons, and therefore in this case we have the mass number as 35, then we have atomic number we have it as 17. Therefore, for us to find the number of neutrons, therefore we are going to get, if we want number of neutrons, then we are going to take mass number minus atomic number, which is in this case our number of neutrons, let's call it n, is equals to mass number, which is 35, minus atomic number, which is 17, and therefore the number of neutrons in this case, which we are going to have n, let's call it n in this case, our value of n is 35 minus 17, which is going to be 18. Therefore, in this case, if they want us to find the number of protons, remember in an electrically neutral atom, protons is equals to the number of electrons. Therefore, in this case, a number of protons is what we call atomic number, and in this case, atomic number is 17. Therefore, the number of protons is equals to 17, which is the same as atomic number. And then we also need the number of electrons. Number of electrons is always equal to the number of protons for an electrically neutral atom. Therefore, in this case, number of electrons is equal to 17 also. Then the number of neutrons is equals to what we have just calculated here, 18. Then question B, write the electron configuration of this element. Electron configuration, we write it using the number of electrons. So if you want the electron configuration, we use the number of electrons in the atom. And in this case, the number of electrons is equals to 17 electrons. And therefore, in this case, we have to fill the first energy level. The first energy level always get 2 electrons. So if we have 17, if we take the 2 electrons in the first energy level, we remain with 15. Then the second energy level will go with 8 electrons. Then now, if you have 15, the electrons which remain, you remove 8, you remain with 7. And therefore, the third energy level will remain with 7 electrons. So these are this is the electron configuration. The first 2 electrons are in the first energy level, 8 electrons are in the second energy level, and 7 electrons are in the outermost energy level, and in this case, which is the third energy level. Then question C, use dots or crosses to show the diagrammatic electron configuration diagram for the element. So in this case, you are supposed to use either dots, like this one here, or you use crosses like this one here to show the diagrammatic electron configuration. So since they want us to use either of the two, I'm going to draw the electron configuration of the two. First, we want to draw dot diagram, and if we need a dot diagram, then we need the electron configuration of the element, and in this case it's chlorine, atomic number 17, whose electron configuration is 2, 8, then 7. So in this case, we will draw the first energy level, or the nuclear, where we will write the number of protons as P is equals to 17. That is the identity of that atom. And then the first energy level, we have said we only have 2 electrons. You put them in pairs like that. Then you go to the second energy level. Sorry, in this case, we said we are going to use dots. So let's use dots here. So in this case, if we are using dots, let's use a black color. So we'll have a dot there and a dot there. That is the first electrons in the first energy level. Then the second energy level, we have 8. 1, 2, 3, 4, 5, 6, then 7 and 8. Those are the electrons in the second energy level. Then now we have the third energy level, which has 7 electrons. And in this case, we are using dots. 1, 2, 3, 4, 5, and 6, and then 7. So in this case, we have used dots to draw the diagrammatic configuration for the diagram. And now, if we want to use crosses, to draw the diagrammatic electron configuration, and in this case, we also need the electron configuration, which is 2, 8, and then 7. Then in this case, we draw the nuclear, where we write P is equals to 17. That is the number of protons, and it gives the chemical identity of the element. Then the first energy level, let's draw the first energy level. We want to draw the first energy level. Let's now use green. So we have 2 electrons, and in this case, we are using crosses. So the first energy level, we have 1, 2 electrons. Then the second energy level here, we have 8 electrons. So we have 1, 2, then 3, 4, 5, 6, 7, and 8. Then the third energy level, we have it like that. And then we have 7 electrons. 1, 2, 3, 4, 5, 6, 7. Question 3. A student mixes cement and water to make concrete. Is this a temporary or a permanent change? Is this a temporary or a permanent change? Explain. Now, when a student mixes cement and water, the type of change that takes place is what we call a permanent change or a permanent chemical change. And this is because when water is added to cement, a chemical reaction called hydration occurs. This creates a new crystalline structure that binds sand and gravel together. Unlike the physical change, like freezing of water, you cannot reverse this process to get the original dry cement back into its powder form. And that's why this one is a permanent change. Then question B, identify 3 differences between temporary change and a permanent change. And one of it is that temporary changes are easily reversed. Temporary changes, you can reverse them easily, just like melting ice, and then while permanent changes are not easily reversed. Permanent changes cannot be reversed easily. Another difference is that for temporary change, no new substance is formed. But in this case, for permanent changes, a new substance is formed with different properties created. Then another difference is that in permanent changes, this one usually involves a significant amount of heat being absorbed or released, while for temporary change, there is no heat, or even a very small amount of heat energy is absorbed or even released. Question 4. You are given a mixture of sand, salt, and iron filings. Describe how you would separate the 3 components. So here you have a mixture of sand, you have salt, and then you have iron filings. And in this case, you are supposed to describe how you can separate these substances. Here, what you need to have is the properties of these substances. Substances like iron, this one is magnetic. This is magnetic material. Therefore, in this case, we can even use a magnet to remove it. Then we remain with sand and salt. For sand and water, in this case, the two cannot be separated using filtration. Therefore, you have to add some water where salt will dissolve and then sand will not dissolve. After that, you do filtration, and then you can even do evaporation or crystallization. So here, for us to describe, you begin with in series of steps. Step 1, you have to use what we call magnetic separation. In magnetic separation, here is when you introduce a magnet to attract the magnetic materials which we have here, which are in this case iron filings. So here, the first thing is that you introduce a magnet which will attract iron filings. Therefore, in this case, you will remain with sand and water. Then the second step is what we call dissolving. And in this case, in dissolving, what you do, you add water to the remaining sand and salt. Here, salt will dissolve in water, while sand will not. So once salt dissolves in water, then you will have sand as a solid, where you remain with the salt, which is a salt solution in the mixture. Then after that, what you do is what we call filtration. In filtration, you have to bring a filter paper where you will filter, where the salt and the water will go down as a filtrate, while sand will remain on the filter paper as a residue. Then after that, you have to go to another step where you can perform what we call either evaporation, where you heat the substance, and the water in the salt solution will evaporate, and then you remain with salt in your evaporating dish. Or you can even perform what we call crystallization, or even a simple distillation, where the water will go and then you remain with a solid sand crystals. So those are the 4 steps which you can be, or which are involved in separating a mixture of sand, salt, and iron filings. Question 5. Explain why filtration cannot be used to separate a mixture of salt and water. So in this case, we are supposed to explain why you cannot use filtration to separate a mixture of salt and water. And in this case, the reason why we cannot separate a mixture of salt and water using filtration is because the salt particles in a solution are too small. When you mix salt and water, salt breaks down into very small pieces which cannot be separated using filtration because they cannot remain on the filter paper as a residue, because those particles are too small such that they can pass through the filter paper. So in this case, you cannot use that because the particles of salt are too small. And if you want to separate a mixture of salt and water, therefore in this case you are advised to use either of the three methods. One is evaporation method, where you heat, water goes, and then salt remain on the evaporating dish. You can also use a crystallization method, where you separate and form crystals from a saturated solution. So you heat the solution until saturation point, and then you cool, and then in that case crystals of salt will form. Or you use a simple distillation, where you heat in a distillation compartment, where water will go as a distillate and then you will remain with salt as a residue. Question 6. List the three methods of softening temporary hard water. Now we have very many methods of softening temporary hard water. In this case, I'm going to list both the one that can be used to soften temporary hardness and some which can be used to soften permanent hardness. One of the method is boiling, and in this case, when you boil, heat causes either magnesium ions, which are responsible for water hardness, or calcium ions, which are also responsible for water hardness, which are found in hydrogen carbonates. Remember, sodium or magnesium, calcium or magnesium hydrogen carbonate, this one is a temporary water hardness, and in this case it decomposes it, and when this one decomposes, the water becomes soft. Another method is distillation, and in this case we use simple distillation. And in simple distillation, what we do, we evaporate the water and then condense it using the Libby condenser, and in this case the minerals, that is magnesium and calcium, remains in the round bottomed flask. Another method which we can use is adding washing soda or sodium carbonate, and in this case chemically precipitates the hardness causing minerals. So this one, it precipitates or it forms solids. It causes the minerals to form into solids which we can separate easily. Then another method that we can use is ion exchange, and in this case we pass water through the resin like a water softener that swaps calcium and iron and magnesium ions for sodium ions. So this resin contains sodium ions. Now if you have hard water which has calcium or magnesium ions, they exchange. Sodium goes to the water, and then magnesium and calcium remains in the resin, and in that process water is softened. Question B, complete the following word equations. We have magnesium hydrogen carbonate plus sodium carbonate. Remember, this is one of the methods that we have said of softening as temporary hard water. And in this case, when we have magnesium hydrogen carbonate, when it reacts with sodium carbonate, it forms two products. One of it is what we call magnesium carbonate. So here you will have magnesium carbonate, then the other product is going to be sodium hydrogen carbonate. Then question C, state two applications of hard water. Hard water has a lot of applications, both at individual level and also at industrial level. And in this case, the first application of hard water is that in health, it provides essential minerals like calcium and magnesium for strong bones and teeth. Remember, your bones are made of calcium and magnesium, and therefore in this case, when you take hard water, you will be rich in calcium and magnesium ions, therefore your bones will be stronger. Then in beer brewing industries, in this case, they prefer hard water because the minerals improve the flavor and also the fermentation of certain types of beers like ales. Then another application is in leather tanning. This is where an industry which turns animal hides into skin. So hard water is mostly preferred in this industry. Question 7. Grade 9 learners of Kapsabet Junior School dipped strips of banana peels in two different solutions, solution X and solution Y, as diagrammed below. So we have strip A, this one here, this is strip A, which is dipped in solution X, which shows the inner part of the peel bending outwards. So in this case, you can see the inner part, the peel is bending outwards. And then we also have solution B, this one here, the second one, which is dipped in solution Y, and it shows the outer part of the peel bending inwards. The outer part of this peel now, in this case, bending inwards. And then the question is, which physiological process was being investigated? In this case, the physiological process which is being investigated is what we call osmosis, and we define osmosis as the movement of water particles from a region of high water concentration to a region of low water concentration through a semi-permeable membrane. Then question B, identify 3 factors that affect the rate of the physiological process mentioned above. The factors which affect the rate of osmosis, which we have just identified, one of it is what we call concentration gradient. And the concentration gradient affect osmosis in such a way that different concentration gradients between the two solutions affect it. If you have a large concentration gradient, osmosis takes place faster, and if you have a small concentration gradient, the diffusion takes place slow. Then another factor which affects osmosis is temperature, and in this case, the higher the temperature, the higher the kinetic energy of particles, and therefore in that case the movement of water molecules will increase. Then the third one is the surface area to volume ratio, and in this case a large surface area allows water molecules to pass through at once, and therefore a large surface area increases the rate of osmosis. Question C, state 2 roles of the above process in living organisms. Roles of osmosis in living organisms, we have very many of them, both in plants and animals. We're going to begin with plants, where it's used to absorb water from the soil by the root air cells. It is through osmosis that plants can absorb water from the soil to the plant through the root air cells. Then in animals, we use osmosis to reabsorption of water in the kidney tubules to prevent dehydration. The reabsorption of water in the kidney tubules is facilitated by this process which we call osmosis. Question 8, define pressure. Pressure, we define it as a force which acts perpendicularly on a surface per unit area, which we give by a mathematical formula as pressure. Let me use this different ink. Pressure is equals to force per unit area, and in this case, this area or this force must act perpendicularly to a surface, or that is 90 degrees to that surface. Then now we have question B, which is also our last question in this case. A teacher or teacher Brand's desk has a mass of 15 kgs. So here we have teacher Brand, and he has a desk which has a mass of 15 kgs. Let's note that. Then the total surface area of the parts of the desk contact with the ground is 0.075 cubic meter or square meter. Then the question is, what pressure does the desk exert on beneath it? So in this case, we have to use the principle that we have just said, that pressure is equals to the force acting perpendicularly per unit area. And in this case, we are supposed to find the pressure. What is the pressure? That's what we are supposed to find. Therefore, it means we have the area and we have the force, or we can get it from the equation that we have. And in this case, the area that we have is 0.075. We have 0.075 square meter. And then in this case, we have force, which we can get. If we have mass, remember force is equals to mass times gravitational field strength. That is what we also call weight. So in this case, the weight that we want to calculate will be the same as the force. And here, if we now calculate the weight, which is mass times gravity, mass is 15 kg times gravitational field strength, which is 10 Newton per kg. So in this case, this kg and this kg will go. Then we will have our weight, which is the same as the force, as 15 times 10, which is going to be 150 Newton. So we have our force as 150 Newton, and then we have our area as this one here, 0.075. And therefore we can calculate our pressure. We can calculate our pressure as force over area, where we have our force as 150 Newton, then divided by an area of 0.075 square meter, which is going to give us a pressure of 2000 Pascal. We can call it Pascal because Pascal is the SI unit of pressure, or we can say our pressure is equals to 2000 Newton per square meter. So that is how we can calculate that. And this one will mark the end of this lesson. If you are new here, welcome. Don't forget to subscribe and also submit your questions on the comment section. And if you are a new member, welcome back. Leave your question, we will answer it as soon as possible.